Okay, in this lesson we are going to begin looking at conic sections and what they are, and specifically at the first conic section, which we will talk about in a minute here. So conic sections come from, first of all, starting with a cone like this. It's actually two cones. It's a cone with two napes is what it's called. Um, so it's basically two cones that are on top of each other, tip to tip like this. And conic sections come from intersecting a plane, which you can kind of think of as a sheet of paper, with this cone with two napes in several different ways. Okay. The most popular conic sections, which we're going to be focusing on in this chapter, um, are ellipses, parabolas, hyperbolas, and there's one that's actually missing, okay? So in this picture over here on the far left, if you think of slicing that cone, and just one cone at a time with a piece of paper at an angle, you get this oval shape, which is an ellipse, okay? If you think of slicing it through the cone kind of more from the top side, but at an angle, you're going to get a parabola, I'm sorry. Again, that only intersects one part of the cone at a time. And then over here in this third picture, if you slice it from top to bottom in some form, you're going to get two branches because it actually intersects both parts of the cone. And then you get these two branches here, and those two branches put together are what is called a hyperbola. Okay, there's one other way that you can take a plane and intersect it with a cone and get one other shape that's not talked about here. And it is kind of like this. If you take that sheet of paper and put it straight through and think of the cone like this, it's kind of hard to picture, but if you put that piece of paper not at an angle but straight through, you will generate a circle in here, okay? So that is one other conic section that we will be talking about this chapter. So these are the ones that we will talk about this chapter. There are other ways that you can intersect a plane or a sheet of paper with these two cones. And here they are pictured right here. So if you stick it right through the tips, you can just get a point. If you stick it through the edges of the cones, you can get a line. And if you stick it right through, perpendicular to the cones, straight through the center, you can get some intersecting lines. We won't be focusing on that too much, although they are conic sections. We are not going to focus on those three right there. Okay, we are going to be focusing on what are called second degree or quadratic equations that are conic sections. So they have some x squareds, y squareds, or both in them. The second degree equations will generate one of these shapes that are on this page right here. And so those are the equations we are going to be focusing on in this chapter. First of all, we're going to focus on a parabola. If you were here, you got to go outside and um, excuse me, generate a parabola with some chalk and some rope and some partners, and you kind of got to figure out the definition of a parabola on your own. But this is the fancy definition, and it's basically the set of all points that are equidistant from the directrix and the focus. So if I could pick any point on this parabola, let's pick a point right here, and I measure the distance to the directrix. And by the way, when you measure distance, it's always done perpendicularly. So if I measure the distance to the directrix and the distance to what's called the focus, this distance and this distance should always be equal no matter where I am on the parabola, okay? So this point right here is important. It's called the focus, and we will talk about that in a little while. When you studied parabolas in the past, you didn't talk about the directrix and you didn't talk about focus, but you did graph parabolas, okay? So these are up-down parabolas, and they both have equations that where your x values are squared. It's your x values that are squared, not your y values. You are used to seeing them in this kind of a format right here. Okay, now it's just a little bit different. This is what is called standard form. So this is called standard form. Okay, you need to know that when your p-value is positive, so right here, your p-value is positive, your parabola will open up. If your p-value is negative, your parabola will open down. Okay, just so you know. And we'll talk more about the focus and the directrix and all that good stuff. This distance right here is really the absolute value of P, but it's P, okay? It represents P. All right, and of course we have left and right parabolas. When you're left, when you have left-right parabolas, it's your y value that's squared. Again, you are used to seeing them like this. Okay, that's not how you're going to see them here. You're going to see them with this equation, although it means very similar things. Um, Here again, if your p-value is positive in this sort of equation, it will open to the right. And if your p-value is negative, it will open to the left, okay? But when your y is squared, you know you have sideways parabolas. When your x is squared, you know they go up and down. When your y is squared, you know they go sideways. There's a whole bunch of formulas here that are here and we can talk about, and we will focus on these as we do a couple of examples. But you can kind of see what's going on, and we'll use those formulas when we do the next couple of problems. Okay? So on this next one, I'm giving you an equation for a parabola, and this is how you are used to seeing it as y equals 1/3 x squared. You're going to, first of all, use that information to find a couple of things. Okay, so first of all, I'm not telling you you have to graph this at all. You don't have to graph it, but I think it's helpful to graph it so that you can answer the questions and kind of talk about some things. So if you want to, you can certainly go to your calculator, plug in the equation 1/3 x squared and get some points to plot. And when you do that, I can tell you that it's going to go through the point 0, 0, and it will go through the point 3, 3, and negative 3, 3. Oops. Okay? And your parabola will end up looking something like this. Okay, no, I certainly did not draw that perfect. I know that it's an up-down parabola because this number right here is positive. Okay, so here's what I want you to know. I also know that it's an up-down parabola because my x value is squared. Okay, if it was my y value that was squared, it would be a left-right parabola. Here, my x value is squared, so I know it's going to be up-down. And because this 1/3 is a positive number, I know it will open up. Okay? All right. So now what we kind of want to do is think about some certain things. If we can figure out what our p-value is, we can answer an awful lot of questions. Okay? So I want you to kind of focus on this. Our standard form for what we know is an up-down parabola is that handy-dandy little formula right there. Okay? I am going to just switch that formula around and put 4py on the left and put x squared on the right, just so that it's the same as the equation that I gave you. Okay? Here's the deal. I need to get this equation into this format. Okay? So what that means is that I need only x squared on the right in this case. Okay, I want x squared on the right, and I want everything else on the left side. So what I'm going to do is I am going to multiply this side by 3 and this side by 3. Those will drop out, and I get 3y equals x squared. Okay, so now you can see this. You can see these match up. You can see these match up. And now what I know is this, that 4p has to be 3. So I'm going to figure out what do I plug in for p so that when I take 4 times that number, I get 3. Obviously, if I divide by 4, p is 3/4. Okay? Here's why that's helpful. Okay, first of all, I want to find my focus. So my focus in this case will be, my p-value is 3/4. So my focus will be 0, 3/4. So I can make my handy little dot at 0, 3/4, which is right there. This, I'm just going to label it as my focus. Okay. My directrix is y equals the opposite of p. So in this case, the opposite of p would be negative 3/4. What that means is that I have this sort of imaginary line down here at negative 3/4, which goes right about there. That is called my directrix. Okay, if I measure My P I know is 3/4. So if I measure this distance, I should get 3/4. And if I measure this distance, I should get 3/4. Okay, because that's what my P value is. All right, so what did I need to find? So I needed to find the focus, which I did. I needed to find the directrix, which I did. And the other thing I need to find is the focal width. And just so you know, the focal width is how wide the parabola is through the focus right here. And so you take that by taking the absolute value of 4p. So here we go. The focal width would be the absolute value of 4 times p, which is 3/4. The 4's cancel. Obviously, I get the absolute value of 3, which is 3. Okay, so the focal width is 3. All right, and that's that first problem. All right, next it says find an equation in standard form of the parabola whose directrix is the line x equals 3. So I'm going to stop right there. First of all, again, I didn't tell you you had to graph it, but I think it's helpful to graph it, or at least barely sketch it so that you can kind of think about what's happening. So I have a directrix of the line that has the line x equals 3. X equals 3 is a vertical line. Just so you know, it's your x values that are being held constant. So x equals 3 is this line right here. This is my directrix. Okay, and then it says I have a focus of -3, 0. So this right here is my focus. I'll just label this. Okay, and I'm going to label this as my directrix. Okay, if I have a vertical directrix and I have a focus over there, what I know is it's a sideways parabola, okay? The vertex will be halfway between the focus and the directrix. So the vertex will be halfway between this point and this point. So that makes this right here have to be the vertex. And the vertex in this case then will be 0, 0. And the focus always has to be inside the vertex, or inside the parabola, opposite of the directrix. So I know that my parabola goes something like this. I'm completely sketching it, but that's all I need to know, okay? You need to now know that this is a sideways parabola, okay? Because it's a sideways parabola, I know that this is my standard form equation, okay? So my goal is to figure out what P is, okay? Here's what I know. My focus is at P0. That means this is P0 right here, and it means that P is -3. Okay, when I write my equation then, I will write it in standard form, which is this equation right here. So I will have y squared equals 4 times -3x, or y squared equals -12x. Okay, notice my p-value is negative, and that makes sense because my parabola opens to the left. Okay, and I think that that was all I had to do there. All right, that will do it until next time.